Okay, so this is a mixed review on limits. So the first question, we're going to find the limits graphically. Okay, so for these questions, I would like you to use the graph to find the limit. These problems can be done algebraically, but the goal for this particular set of problems is to see if you can use the graph to find the limit. So that's the related function for the graph that we're going to be using to find the limit. So let me sketch the graph for you. We have an asymptote on -2, a vertical asymptote on -2, and a horizontal asymptote on 1. And let's just sketch the graph. This is basically what it looks like. Let's do that again. So it goes through 0. Okay, something like that. Alright, so the question is, what's the limit of this function as x approaches 2 from the right? The direction is specified. Okay? Alright, so if this is, let's say this right here, this value is positive 2, that's what we are approaching. So remember that whenever you are approaching a vertical asymptote, your limit is always going to be plus infinity or negative infinity. If you're approaching a point, your limit is going to be the y-coordinate, but if you're approaching a vertical asymptote, your limit is going to be plus or minus infinity. If you're heading upwards, your answer is going to be infinity. If you're heading downwards, it's going to be negative infinity. So let's take a look at what's happening here. On the top right here, this asymptote is heading to infinity, and then here, negative infinity. So what do you see happening? If you're approaching -2, this is from the right. If you're approaching positive 2 from the right direction, you're traveling along this graph. In what direction are you headed? You're heading upwards. Okay? You're getting infinitely close to this asymptote in the upward direction. So this limit is going to simply be infinity. Okay, let's take a look at question number 2. So let's say for question 2, you're to find the limit as x approaches 2 of x minus 2 divided by x squared minus 4. Using the graph, you take a look at this limit right here. There's no direction specified. So we're going to be approaching from both sides since no direction is specified. There is an invisible positive and negative attached to every value that you're approaching where the direction is not specified. So in this particular problem, we're going to take a look at the left-hand limit. Limit as x approaches 2 from the left. We're going to be also taking a look at the right-hand limit. Limit as x approaches 2 from the right. Whatever the answer is, that will be, well, if the two answers are the same, then that will be the value of the double-sided limits, which is this one up here. Okay? If they're different, then the limit does not exist. Let's name them real quick. So this guy right here, I'm going to call it the LHL, left-hand limit. This guy right here, I'm going to call him the RHL, the right-hand limit. And then the original problem right here, let's call it the DSL, double-sided limit. In order for the DSL to exist, the left-hand limit and the right-hand limit must be the same. Okay? So we're going to use the graph to approach 2 from the left and right and see if they're the same. That will mean the limit exists, and that's the value. So we're taking a look at -2 right here. Okay? We are approaching a point. Whenever you're approaching a point, the limit is the y-coordinate. Whenever you're approaching a point, the limit is the y-coordinate. So we're going to trace this to the y-axis. Okay? So we're tracing this to the y-axis, whatever the y-coordinate is right there. This value here, let's say it's 1 over 4, 0.25, sorry. So let's call that 1 over 4, okay? So you can see that when you're approaching 2 from the left, you're going in this direction right here. You're approaching 2 from the left. That's the left-hand limit. Okay? The answer is the y-coordinate of the open circle you're approaching, which is 1 over 4. It doesn't matter if it's open or closed. Now, how about if you're approaching 2 from the right? If you're approaching 2 from the right, you're approaching the same point. So the answer is going to be the same y-coordinate that you were approaching before, which is 1 over 4. Okay? Now, since the right-hand limit and the left-hand limit are both the same, that tells you that the double-sided limit is going to be that value. If they're different, that means the limit does not exist. All right, for number 5, we have number 3, we want to find the limit as x approaches -3 from the right of -4x over x plus 3. So since this is a finite limit, we're going to substitute first and see what happens. So we substitute this negative, we can group it with associate it with the numerator or denominator. Let's put it on the top. So we can put this as -4 times, plug in that number, -3 from the right, divided by, at the bottom you have -3 from the right plus 3. Okay? Let me make that green. -3 from the right plus 3. And then we just simplify this. Okay? So what you have to remember is that the way how to write your infinitesimals using infinity. So 0 from the right is the same thing as 1 over infinity. And you also have to remember that 0 from the left is 1 over -infinity. Okay? All right, just keep that in mind. Now, let's simplify this. In the numerator, you can do this arithmetically. You don't have to break it down. You have -4 times -3 from the right. What you do is multiply the numbers. 4 times 3 gives you 12. Minus times minus gives you plus. But notice this. This minus impacts the sign of the number, and it also impacts the direction. Okay? So this will now become 12 from the left. For the denominator, we need to break this down so we can know what it is. So let's make a number line. And we have, what do we have? We have -3. We have -2 to the right. And we have -4 to the left. So the question is, what is -3 from the right? If you think about it, in between these two numbers is -2.5. If you get really, really close to -3 from the right, because we're approaching -3 from the right, this is going to be something like -2.99. So if you get infinitely close to -3 from the right, you will have -2.99, an infinite number of 9s, 99 plus 3. -2.999 plus 3. What you do whenever the signs are different, just like in basic arithmetic, you subtract and you keep the sign of the bigger. So 2.999 minus 3, 3 minus 2.999 is 0.00, infinite number of zeros, 0, 1. The bigger number is positive, so your result is going to be positive. We can write this number using infinitesimals. This is a very small positive number, 0 from the right. This becomes 12 from the left divided by 0 from the right. A very, very small positive number can be written using infinity. This can be written as 1 over infinity. Okay? And now what you do next is you drop, change, flip. 12 from the left times infinity over 1. If you multiply any positive number by positive infinity, your answer is going to be infinity. Now for number 4, what if we were to find the limit as x approaches pi from the left of negative cotangent x? So we're going to substitute. If we substitute, we have negative cotangent pi from the left. Okay? So you have to remember your quotient identities, which states that cotangent theta is cosine theta divided by tan theta. Sorry, sine theta. Alright, so I'm going to reduce this into a sine and cosine case so I can use your graphs to finish it off. You also have to remember that cosine theta graph is your little cups, and your sine theta graph are your s's. Bam. Okay? So we're going to reduce this into negative cosine pi from the left divided by sine of pi from the left, because cotangent is cosine over sine. Alright, now we're going to make use of the graphs in answering the questions. So we're going to start off with the cosine graph. Okay, so for cosine, let's sketch the cosine graph. It oscillates between 1 and negative 1. And then let's say that's pi over 2, and that's pi, and that's 3 pi over 2. So this pi right here. So cosine are like your cups. Let's do that again. Okay, so what we're doing is we're approaching a point. We're approaching pi from the left side. Okay, we're approaching pi from the left. If you're approaching pi from the left, along the graph, what's happening is that you are descending towards that point. If you're descending towards that point, your limit is going to be what you get when you descend towards the corresponding y coordinate. So you're going to be descending towards negative 1. So coming from the top towards negative 1 is negative 1 from the top, or negative 1 with a positive direction. Alright, so this basically helps us to see that cosine of pi from the left is simply negative 1 from the right. For the denominator, we're going to call on our sine graph to assist us to evaluate what sine of pi from the left is. So let's take a look at what the sine graph looks like and compute sine of pi from the left. Alright, so your sine graphs are like your s's. So that's just a portion of the sine graph. The sine wave oscillates between 1 and negative 1, just like your cosine graph. So that's 1, and that's negative 1. And this is pi right here. Alright, so what we're doing is we are approaching pi from the left. Alright, so as we are approaching pi from the left, is as though we are going along this line, we are descending towards this point. We're looking at the y-coordinate of this point. So the y-coordinate of this point is 0. We are approaching that number from above. So we are descending towards 0 from above. Okay, so that's going to be 0 from the top or 0 from the right. So we'll put that in here. We're going to have, what are we going to have? Sine of pi from the left is going to be 0 from the top. Okay? And then here you have a minus and a minus. You can just multiply. Well, we've got to be careful here with the multiplication. Let's leave it out for a second. So, or we can multiply. Let's just multiply. So what I'm going to do is I'm going to distribute this minus with the top here. Okay? So just to review what we talked about before, when you're multiplying a directional number by negative, that negativity impacts the sign, and it also impacts the direction. So negative 1 from the right multiplied by negative is going to turn it into positive 1 from the left, divided by 0 from the right. Now 0 from the right, using our knowledge of infinitesimals, is 1 over infinity. You drop, change, flip, multiply 1 by infinity over 1, and your final answer is infinity. Okay, so for the last one, problem 5, what if we want to find the limit as x approaches negative 2 from the left of a function? A piecewise defined function defined as f of x is 2x plus 1 when x is less than negative 2, and f of x has a value of 1 when x is greater than or equal to negative 2. So what we're going to do first is we're going to give ourselves a visual, okay? So we're going to draw a number line and see what's where and know which function is going to be live. The split happens at negative 2. Let's call the top function 1 and the bottom function 2. For x is less than 2, we're taking a look at everything to the left of 2, okay? Let me use an arrow for that. Everything to the left of 2. So all this right here, that is region 2. No. Okay, so for less than, that's region 1. So this is 1 right here. Okay, x is less than negative 2. So for x is less than negative 2, we're looking at 2x plus 1. That's what's active here. X is less than negative 2. And then on the other side, we have greater than or equal to. So that's a closed circle. So if you're on the point or anything to the right of that point, you have the second one active. So you're going it like this. So for this one, you have the second function active. So this is region 2, interval 2, where x is greater than or equal to negative 2. And the function that's active here is 1. So the question is, which one are we going to be using for this problem? When you're approaching negative 2 from the left, you're going to be using function 1. And when you're approaching negative 2 from the right, you're going to be using function 2. In this problem, we're approaching negative 2 from the left, so we're going to be using function 1. So this problem simply becomes the limit as x approaches negative 2 from the left of the top function, which is 2x plus 1. To finish this up, you simply substitute. You have 2 times negative 2 from the left plus 1 When you double negative 2 from the left, the sign and the direction remains the same, so it's simply going to be negative 4 from the left plus 1. Alright, so negative 4 from the left, if you think about what this is, negative 4 from the left is, let's visualize that with a number line real quick. Negative 4 from the left with a number line, this is negative 4 right here, and then negative 3 is to the right, and negative 5 is to the left. So negative 4 from the left, you're coming from this direction. So between them is negative 4.5. So if you get really close to negative 4 from the left, what you're looking at is negative 4.00, infinite number of zeros, 0, 1. So this is negative 4.00, infinite number of 0, 0, 1 plus 1. If we subtract these two, subtract and keep the sign of the bigger, this is going to be negative 3.00, infinite number of 0, 0, 1. That is negative 3 from the left. What are you approaching here? You are approaching negative 3, and that's your final answer.